Representing linear, non-proportional relationships. Linear equation. An equation whose solution form a straight line on a coordinate plane. Alright, so representing linear non-proportional relationship. Remember that proportional has to pass through the origin and be a straight line. Well, today we're going to talk about just straight lines that don't necessarily pass through the origin. Let's look at example 1. The equation 3x plus 2 gives the total charge y for bowling X games at Baxter Bowling Lanes based on the prices shown. Make a table of values for the situation. So if we look at the first one, it is just 3 times 1 plus 2. 3 times 1 is 3, 3 plus 2 is 5. Then you have 3 times 2 plus 2. 3 times 2 is 6, 6 plus 2 is 8. Then you have 3 times 3 plus 2. 3 times 3 is 9, 9 plus 2 is 11. Then 3 times 4 is 12, 12 plus 2 is 14. Okay, so this is just substituting. Okay, if we're going to look at this, this is a linear equation, but it is not a proportional relationship because of this plus 2 right here. This is going to intersect the y-axis at 2. Okay, so it's not going to be through the origin. It is a linear relationship because it is in the format of y equals mx plus b. All right, let's go to number 1. All right, so Francisco makes $12 per hour doing part-time work on Saturdays. He spends $4 on transportation to and from work. The equation y equals 12x minus 4 gives us earnings y after transportation cost for working x hours. Make a table of values for the situation. Well, let's just make it as simple as possible. So let's do 1, 2, 3, and 4. Alright, so if we do 12 times 1 minus 4. 12 times 1 is 12. 12 minus 4 is 8. Okay, 12 times 2 is 24. 24 minus 4 is 20. 12 times 3 is 36. 36 minus 4 is going to be 32. And lastly, 12 times 4 is 48. 48 minus 4 will get me 44. Alright, so this is a linear relationship. It is in the format of y equals mx plus b. We have y equals 12x minus 4. It's going to intersect the y-axis at negative 4 and have a slope of 12. One way to check your table of values and to check your equation is to go into your calculator and go into the y equals up here in the top left. Type in the equation 12x minus 4. Alright, and then second graph. We can check our table. So we have 1, 8 over here, 220, 332, 444. Also, we can take a look at our graph. This is what our graph looks like. It is a linear equation. Okay, so if you want the calculator, to type it in, we have the y equals key, which is in the top left. You're going to type the equation. After you type the equation, you're going to hit second, and then the graph key, which is in the top right, and to get more table. All right, let's flip to the back side. Example 2. On example 2, it says the diameter of a Douglas fir tree is currently 10 inches when measured at chest height. Over the next 50 years, the diameter is expected to increase by an average growth rate of 2/5 inch per year. The equation y equals 2/5 x plus 10 gives y the diameter of the tree in inches after x year. Draw a graph of the equation. So what we're looking at here is just our input-output table. If you have 0, 10, 20, 30, and 50, you have 2/5 x plus 10. You have 2/5 times 0 plus 10. Anything times 0 is 0. 0 plus 10 is 10. Okay, then you have 2/5 times 10. This would get you 4. 4 plus 10 is 14. Then you have 2/5 times 20. This would get you 8. 8 plus 10 is 18. You have 2/5 times 30. This would get you 12. 12 plus 10 is 22. And then you have 2/5 times 50. This will get you 20. 20 plus 10 is 30. Alright, you could graph it on a coordinate plane, but you notice it's not proportional. Yes, it's linear. Also, like we did on the last example, you can go to y equals. You can type in 2/5 2/5 x plus 10. And you can go to second graph and check so yeah, we need to go scroll down if we can, because we did 10. So 10 is 14. Uh-oh. 20 is 18, and so on. And if you want to look at the graph, this is what our graph would look like. Okay, let's go to the next one. Make a table and graph the solutions of the equation. So we have our input-output table, negative 2x plus 1. So we have negative 1, 0, 1, and 2. Negative 2 times negative 1 is 2. 2 plus 1 is 3. Negative 2 times 0 is 0. 0 plus 1 is 1. Negative 2 times 1 is negative 2. Negative 2 plus 1 is negative 1. Negative 2 times 2 is negative 4. Negative 4 plus 1 is negative 3. When we graph the ordered pair, negative 1 up 3, 0, 1, 1, negative 1, and 2, negative 3, form our straight line. Okay, and so that is our line. If you want to check it in the table, you can do the same thing that we've done in the last example. We have negative 2x plus 1 and delete the rest of this. Okay, you can go to your table and check it out. So we have 0, 1, 1, negative 1, 2, negative 3. If you want to look at the graph, it looks like this with a negative slope. All right.